let's do some examples of some geometric problems, but we also need to talk about why they are geometric. For question number 107, sorry, this is a little blurry. It says, to start her old lawnmower, Rita has to pull a cord and hope for some luck. I can relate to that. On any given or any particular pull, the mower has a 20% chance of starting. Find the probability it takes her exactly 3 pulls to start the mower. Okay, so is this binary? Yes, because the mower either starts or does not. Is it independent? Yes, because knowing if one trial works doesn't affect the probability of the next trial. I'm going to say poll instead of trial so that I have context in there, but basically, like, if a poll works one time, it doesn't necessarily mean it's going to work the next time. Like, the probability doesn't change. Now, there actually is not a set number of trials here. I think that sometimes people see the 3 as a set number of trials, but this is actually a trials until success situation. 3 trials until success. So that means that, like, it fails twice and then works once. Like, that's what's happening. And then the probability of success is 0.20. So that means that this is geometric. Personally, when it's something like this, when it's an exact question, I prefer just to, like, calculate it with the formula instead of trying to use like a CDF or a PDF. So if it takes 3 pulls to start the mower, that means it fails twice. And then it works once. So, and that's the only, it has to go in that order. There's only one combination of a way that that happens. So I get 0.128. That is the probability that it takes 3 times for it to start, exactly. Now for part B, find the probability that it takes her more than 6 pulls. This is, so more, we have to be careful. More than 6 pulls is actually 7 or more. Like, we're not including the 6. This is going to be a CDF situation. And because I'm doing like trials until success, I know that this is for geometric. So I am going to go to probability, distributions. You have to actually scroll down on this little arrow until you get to geometric. So geometric CDF, probability of success was 20%. My lower bound was 7, and then technically my upper bound is infinity because she could keep pulling and pulling and pulling the lawnmower. They didn't give us a set number of trials. That's what makes this not binomial. So it goes to infinity. So 0.262. Now, actually, I should have written some work. Here's what the work is going to look like. Okay, so we're going to actually show our work by writing out geometric CDF. I'm essentially going to copy what I have here, but I need to label. Okay, so I copied down what we had from the calculator right here. So we have geometric CDF, P, lower bound, upper bound, and that equals 26.2%. Okay, question number 11, calculate and interpret the mean of X, calculate and interpret the standard deviation. If I skim this, the probability of the first digit of the amount that's randomly chosen is an 8 or a 9 is a 0.097. Suppose we examine the randomly selected invoices from a vendor until you find one that begins with an 8 or a 9. So I know this is geometric because of the until part. It is going to be, so binary, it is binary because it's basically an 8 or a 9 or not. It's independent because knowing one invoice digit doesn't change the probability of the next. It is select until you find one with an 8 or 9. Okay, so we've got the trials until success. And then my probability of success is 0.097. Okay, calculate and interpret the mean of x. So I already established that this is geometric because I just checked bits. Here's where the formula sheet is going to be your friend. So you go to the formula sheet. Right in the middle of the first page, we have this box. I've got geometric stuff here. So notice there's the mean and there's the standard deviation. So these problems are actually really easy because all you have to do is plug numbers in. But if you forget that you have a formula sheet that has everything you need on it, then it is hard because you're like, how in the world do I find this mean and standard deviation? So I'm going to cheat a little bit here because I'm running out of time to do this. If I go to the answers over here, I can see that the mean is going to be 10.31 because I did 1. They would do 1 divided by P. The interpretation is if many, many invoices are selected, the average number of invoices we would expect to examine in order to find the first one with an amount that begins with an 8 or 9 is about 10.31 invoices. So this is so wordy, but it's, you know, you're basically having to be like, if we do many, many of whatever, so in this case, it's selecting many, many invoices. And then you have to like actually use the words from the problem, which again, it's like kind of long and obnoxious. But notice that they said the average number of invoices we would expect to examine, and then right here, until you find one whose amount begins with an 8 or a 9, like you had to just like copy that straight down, is this. Here's the standard deviation formula. You just plug those numbers in. Again, it's if many, many invoices are selected, the number of invoices it will take to get the first invoice with an amount that begins with 8 or 9 typically varies by about 9.797 invoices from the mean of 10.31 invoices. And then lastly, this is related, question number 13. Would you be surprised if it took 40 or more invoices to find the first one with an amount that starts with an 8 or a 9? So 40 or more, this is a geometric situation, geometric CDF. So to answer if I'm surprised, I should see what the probability is for it to actually happen. So I go to distributions, I got to scroll down, geometric CDF. Probability of success, I think it was that. Let's look. 0.097, yep. Okay, this is the probability of success. They said 40 or more, so my lower bound is 40, and then my upper bound is like a bunch of 9s. I also could do 1 through 39, and then do the complement, do 1 minus that. But this is also just as easy, I think, since we have a calculator. So it's like a 1.9% chance that that would happen. So the question would be, do you think that's surprising or not? If we go based off of our 5% rule, then we would say that that is surprising. Lower bound, upper bound. So 1.9% is less than 5%. So yes, it would be surprising. So is it possible to take 40 or more invoices to get an 8 or a 9? Yes, but it's only like a 1 to 2% chance of that happening. So it is pretty surprising.